right? So my name is Ed Sierra. Some of you know me. I'm the Laboratory Occurrence Reporting Processing System Coordinator. We call that ORPS. So when anything goes wrong at the laboratory, I usually get involved and help out. And my learned colleague here, Steve Moss, is helping out today. He's the PSD, Photon Science Directorate Authorization Basis Manager. He's also the Conduct of Ops Manager. And he's an expert in this area, so he's here to field the graduate level questions that I'm sure you'll have. But I want to start out by, well, what we're here to talk about is the authorization basis documents. This is actually two parts: authorization basis documents and unreviewed safety issue determination procedure. So let me give you the big picture to start out with. We've taken a graded approach to this training. You guys today are going to get the awareness training. So far, 87 individuals have gotten the awareness training. You can go on to get the screener training, and I'm going to go into a little more detail what that means. And then you can go on further and get the evaluator training. So if you were to get the screener training, and by the way, 17 people have gotten that training, you would of course already have the awareness training this session, and then you would have to read and acknowledge the authorization basis documents, and then you'd be a screener. You could then go on to become an evaluator. Right now we have 5 evaluators. Of course, you'll be qualified as a screener. Then, though, to become an evaluator, you would have a sit down with Steve Moss, and he would really run you through the paces and fine-tune you, and you'd become an evaluator. Right now, those 5 evaluators reside within these spaces. Some of them own accredited controls, which we're going to talk about and define what accredited control is. And also some of them come from these areas of ESH. So we got to start out with an instructional goal. If I was to turn this into my own words, I would say basically the hope is that after this session, you'll be able to recognize when a credited control has been impacted, or perhaps you guys are thinking about doing something that may impact the credited control, and you will tell somebody about it, and that word will get to Steve. That's what we're hoping comes out of this training. And stop me any time along the way with questions.
Ben, I have one.
Yes.
Can we get these lights?
The lights? Slides. Oh yes, certainly you can get the slides. Yep. So enabling objectives, which help us get to the goal, is you guys will be able to list the 2 different authorization basis documents, which we're going to talk about. We'll be able to define credited control. You'll recognize, certainly in your area, the engineering credited controls that are required to be in place during operation. We'll discuss the precautions and limitations which come from the USI procedure. And then finally, we'll wrap up. We'll take a look at the 3 significant attachments in the procedure. The first 2 have to do with just big picture flow diagrams on the process. And then the last one, which I'll hand out, contains the 8 screening questions. Not that you're screeners, but if you have a sense of these 8 questions, of course, then you'll be better able to tell somebody, hey, we think something has changed that needs to be looked at. Really, this is a configuration control, one of the configuration control methods. Processes, okay. So I always like to start out with a quote in my training sessions. I think that's applicable. Anybody know who said that? Besides Steve? I'll give you a hint. One of America's founding fathers. He is also a former member of the Royal Society, a fellow of the Royal Society, former scientist.
Postmaster General of the United States.
There you go. There he is. Okay, lived a nice long life, certainly for those days. Franklin.
And a full life.
All right, so what drives us? What drives the USI process? What drives authorization basis documents? Well, of course, DOE drives it typically. And so we do have a DOE order titled Safety of Accelerated Facilities. There's a companion guide, which was recently revised and issued in August. Accelerated Facility Safety Implementation Guide. Of course, what we do here at the laboratory is we take these DOE guides and orders, and we take out the minimum we need from those guides, at least a minimum, to develop our SBMS, or Standards-Based Management System subject area. So we have a subject area here titled Accelerator Safety, which governs all the work, all the operations that occur at the accelerators on the site.
It basically explains how we on this site implement the rules and regulations that are being invoked by DOE, so that anybody and everybody on the site knows what has to be done and in fact commits to doing those things.
In the order, it tells us that accelerator safety programs must have these documents: the safety assessment documents, which we call the SAD, the accelerator safety envelope, which we call the ACE, and our USI process. And we do have these in place. Specifically concerning the SAD, we have version 2, which was issued in July, and our ACE was recently issued, or version 1 was issued in May. So we have these two authorization basis documents, which we're going to touch on. In the future, they will continue to be revised, because right now they don't include all the beam lines or top-off operations. Steve, you want to say something about that?
Let me speak briefly on that. As you gentlemen already know, the project beam lines were included in the SAD, and that's why we're able to proceed with them right now. The SAD and the associated ACE originated in May of 2014. We subsequently had to address findings that came up out of the accelerated readiness review process pertaining not only to beam lines but other aspects of our operation, and that resulted in a second version of the SAD being implemented while still keeping the first version of the ACE. The ACE document, the Accelerator Safety Envelope, is in fact the operating license for the accelerator. It gives the hard and fast limits in terms of current and energy and equipment being on and equipment being off, and commitments to keep the polarity a certain way, and all of these things. Those are the hard and fast rules that we have very limited latitude with. The SAD is the more general document. It describes the analysis, the accidents that were analyzed, and the basis for certain commitments being included in the ACE, and is more of an analytical and descriptive document. But there are some commitments in the SAD that, while they don't reflect in specific requirements in the ACE, are still considered commitments. For example, compliance with the shielding policy and radiation exposure policy of the directorate. That's one of our commitments too. In terms of top-off operations, that was specifically excluded from the current authorization basis document. That will require, well, in fact, it will require a positive USI, which will result in a change to both the SAD and, in all likelihood, to the ACE. There will be limits, requirements, credited controls, MCIs associated with top-off that will have to be worked into these documents. The ACE document itself, strictly speaking, has to be reviewed and approved by DOE. So we can't operate without their sign-off on that. The SAD document is basically our own document. We let DOE see it. We let them comment on it. We don't have to get their formal authorization. In fact, they do not specifically approve that document. They just approve the limits that come out of that document. And in fact, one of the chapters within the SAD is the derivation of all the limits and requirements in the ACE. That typically is Chapter 5 in the SAD, where you find the analytical basis for the ACE limits. Now, the beam lines, as you know, some of the beam lines, the current set that we started operating this morning with, were included in the original document. We know there are more, and they will be coming. And when they are up and when they pass muster, they will be in the book and they will be added. And then, depending on the limits of those beam lines, what they are intended to do, how they operate, they may fall in under the current authorization basis if they represent no new hazards, no increasing of the safety envelope, so we could just incorporate them as an additional beam line. If they represent something totally new and exotic that we haven't analyzed before, or we haven't considered the types of potential accidents that there might be, then we would have to go back and revisit the ACE and go back to DOE for prior permission. That's the key of the USI process, this concept of DOE has agreed to a particular safety envelope, and as long as what we intend to do does not expand that envelope or go outside that envelope or go to some unknown and unanalyzed state which may or may not be in that envelope, then we could pretty much do what we want. But as soon as we get to those borders, or as soon as we don't know for sure that we're going to be in those borders, then we have to go to DOE for permission first.
Okay.
Thanks.
So throughout the presentation, there'll be some repetition, but that's good. That's by design. So you'll hear it more than once. So back to the SAD, or the Safety Assessment Document, as Steve alluded to, this is a document that really analyzes the risk to running the machine, both to the workers, the population, the environment. Okay? So that's all discussed in the SAD to include the technical basis for the accelerated safety envelope, which we'll discuss in more detail. But this gives you a list of the things that are discussed in the SAD, all these different kinds of risk. Now, for the most part, they're already addressed in our SBMS standard, procedures. There are two on this list that, however, we had to take a closer look because they weren't looked at by the laboratory procedures. And those are the cryogens, oxygen deficiency hazards, and the ionizing radiation.
Let me jump in here. What Ed is trying to say, and what he is right in saying, is that everywhere on site we have these occupational risks at hand. And we nominally take care of them by applying the SBMS subject area guidance. And in those cases, as long as we're doing what the SBMS subject area says, and we don't require any special engineering controls or any special personal protection devices above and beyond what's routine everywhere on site, then we don't have to have any special commitments in the ACE. Our only commitment is we will do what everybody else does on site, and that is apply the SBMS subject area. But in the case of ionizing radiation, we have a potential for a maximum credible incident, which is some of those accidents like missteering of beam or slamming beam into various parts of the machine where it's not intended to be focused, that can create radiation fields that exceed or that require additional controls be in place, whether they be shielding, supplemental shielding, burn-through devices, other considerations, automatic cutoff devices that measure the current that prevent you from continuing to send too much current or too much energy through the machine that could result in a problem. Because of those requirements and those responses to those issues and insults, those maximum credible incidents exceed the standard subject area protections and require commitments within the ACE based on the analysis in the SAD. Cryogens and ODH is relatively new. We did not need to have credited controls for that just to run the accelerator itself. But when we started the operation of the beam lines, because some of the beam lines, and more than some, many of the beam lines, have direct feeds of liquid nitrogen piped into the hutches and enclosures, there's potential for failure modes and accidents where almost unlimited quantities of liquid nitrogen can be spilled into an enclosure or a hutch, and this will result in ODH0 or ODH1 possibilities, mandating the use of oxygen monitors, oxygen alarms, and sensors. Now, it happened that the fact that we use that did not in and of itself create the credited control for its use. There are many places on site where we have oxygen monitors, oxygen sensors, and ODH alarms. Superconducting Magnet Division has them in 902 at many places, and of course RIC has them. But because of the large number that we anticipate associated with 60 beam lines and maybe up to 120 hutches, the thought was that in all likelihood some of those may fail. And because they may fail when they're needed to operate or at any time in between the times that they have been operating, the laboratory ESH committee decided that it would be prudent for us to make that a commitment, a credited control, which means it's in the ASE, and additionally, we had to prepare for and invoke authorized alternatives. what to do if we want to continue to operate in the enclosure and with the enclosure if for any reason the ODH monitor is out of work, is kaput, out of cal, not working properly. So we have those built into the process, the idea of these authorized alternatives. We also have the commitment to test them at a particular frequency and replace them at a particular frequency. And it has to do with the number of them that we have all in use by, for example, not people who are dedicated to the use and training of this machine all the time. We're going to be having a lot of transient experimenters and beamline guests that'll be operating in these areas, and we needed equipment that was going to be reliable to protect them, because we can't rely on them being trained and qualified the same way our control room operators would be, or our authorized beamline scientists are. So that's basically that story.
So moving into the ACE, the Accelerated Safety Envelope. By the way, it's only 5 pages, the ACE, where the SAD is on the order of at least 100
120,
pages.
140,
Okay.
not including appendices.
So as Steve said, what's the purpose of the ACE? Well, the ACE, the purpose of it is it's simply an agreement. B&L and DOE shook hands, and they said, this is how we're going to operate the machine. We're not going to go outside these bounds. We're really going to adhere to these defined credited controls. So it's a safety agreement.
It's more than a safety agreement. It's an insurance policy. This is based on rules and regs and ideas that go back to the very beginning of the atomic age, when the government itself had facilities that it could not get commercial insurance for. And that started out as nuclear facilities, and it subsequently worked its way down to accelerated facilities too, in that DOE is not only the owner of the facility, they are also the insurer of the facility, and they are responsible for making good any damage or harm that comes to pass as a result of the operation of that facility. And because they are the insurer and they want to make sure they don't have to pay out needlessly, they invoke these safety rules, and we commit to them in order for them to continue to maintain our coverage and allow us to operate the machine. It's not just that they own it, it's that they are responsible for any damage to individuals who work here, members of the public, or the environment. Now granted, as we all know, this machine is not a RIC machine. We're not creating large amounts of, terrific amounts of radiation and a lot of activation. We're not going to have a big impact in terms of contamination or activation in our own facility. And one would really have to go out of their way to violate the planned operations in order to expose themselves to anything like a significant amount of radiation. Still in all, that's where this comes from. This is in essence our commitment to do what is in accordance with our policy with DOE in order for them to maintain the policy.
Okay. The ACE. Again, it's only like 5 pages, broken down into these 4 sections. Intro, credit control supports, and calibration and testing, etc., maintenance. Our talk is going to touch upon credited controls and also the other ones, but we're focused on the credited controls. So what is a credited control? This is the interaction part. What do you guys think a credited control is? What does that mean to you?
Especially to people at the beam line. What do you think of as your credited controls?
Voltage sensor,
Certainly.
well, shielding, PPS.
Yes, yes.
Okay. So those are the credited controls,
Yeah.
but what does it mean? Why are they credited controls? What does it mean to be a credited control?
So when you have it, you essentially have to credit to operate the city safely.
Okay.
Those are being verified. Those have to be verified before you can take credit.
Yes. So let's see what we have on the slide. They have been determined through the analysis as essential, as you said, for people, the public, the environment. They come under a higher scrutiny concerning surveillance, maintenance, etc. And they are listed in both the SAD and the ACE.
One other point that you did make that is not up on the slide is this idea of configuration management, that we have to assure ourselves before we start up our operations that everything that we say is there or has been verified as being there since the last time we've operated it or for the first time we've operated it. And we go so far as to actually take pictures of the layout of the shielding to make sure that if we ever have to undo the shielding to reach some component that's hidden underneath the shielding, we're able to put it back exactly the same way so as not to create some unanalyzed streaming issue.
Okay, so now I'm just going to show you some of the credited controls within the ACE. So what this is talking about is what are the credited controls in the LINAC, the booster, and the storage ring. Now I didn't include all the numbers because we're not going to memorize those numbers here, but it's mainly about the electron beam and associated numbers. So I just give you a sense of that here. I would imagine the control room operators are more familiar with this.
Yes, and as they would be. And it's interesting to note, right now we have only 2 documents. The original version of this course had 4 documents. We didn't even have all 6 yet because each of these was a commissioning set of authorization basis documents until we got the okay for routine operations. We had a LINAC, SAD, and ACE for commissioning. We had a booster, SAD, and ACE for commissioning. And we even ultimately got the storage ring, SAD, and ACE for commissioning, but that wasn't even part of the course then because we had gotten it after we had started this whole process. We were able to roll these all up into single documents. The single combined routine ops SAD includes information from all of these and cuts out some also, thankfully. Same thing with the ACE. The ACE combines information from each of their ACEs and doesn't have to repeat it as much each and every time.
That's the project beam lines, as you said.
Now, plus we have the project beam lines additional commitments in there too now. That's the main difference between the commissioning ACEs and the routine ops ACEs, the addition of the beam lines, because in the storage ring commissioning documents, we did not include the beam lines at that point. That was one of the things we had to incorporate. And that became one of the sticking points, or one of the most difficult aspects of the IRP, IRR, and ARR process for beam lines. This idea that we would be able to authorize our own beam lines in the future without having to go all the way to the ARR process, which is the DOE process of outside reviewers coming in to verify that you internally did an adequate IRR.
Okay, so more about credited controls. And this has to do now with the radiation hazard. So we kind of already talked about it a little bit, but there's credited controls concerning gates, fencing, berms. In fact, Steve, I'll give you 30 seconds. All right, I'll give you a minute.
All right.
Go over the berm part that was already noted in the past.
As part of the ARR, IRR, IRP process, even during the commissioning of the separate sectors of the accelerator, the components of the accelerator, it was discovered by one of our own reviewers, whose name shall be left out for protection of the guilty, that the berms were never actually measured to confirm to the commitment in the ACE and in the SAD. So he called for literally a survey to be made of the berms to confirm that they were in fact the appropriate thickness. This is earthen shielding on top of the various components, typically the LINAC and booster. And lo and behold, it was not up to spec. In some cases, it was off by over a foot. Now, as it turned out, this was not a real concern in terms of a hazard. It's just a concern in not meeting your commitment. Because in point of fact, we had subsequently increased the security around the area and locked and gated that whole area so nobody could inadvertently walk into that region and be standing on that berm when the machine was operating without people knowing about it and having, compromised a locked gate as it was. But that represented a positive USI, and that was a problem because when you discover something that is not up to the requirements and the standards in your ACE and your SAD in the field after the fact, that's a big bugaboo with DOE.
Okay, so continuing, of course, area rad monitoring, credited controls. We've been discussing shielding already, lead shielding, berms, etc. Burn-through devices have to be in place and certified. And of course, we hope that there's at least one operator around when the place is running.
Qualified operator.
Yes.
So So you don't use the PPS language in that slide? Is it part of that? Is it captured somewhere? Oh, it's just over there.
Yeah.
Okay.
Yep.
Sorry, I missed that.
Okay.
It's all right.
So, and we already touched upon the idea of the ODHs in the experimental enclosures, but as part of credited controls, we have to monitor the oxygen levels. We have to have an alarm system. Of course, that alarm system comes under scrutiny and surveillance, and we have alarms both inside and outside the enclosures to alert people. Now, something Steve mentioned in passing that we're not going into great detail here, there are, if you have an issue with accredited control, there are alternatives,
Authorized alternatives.
authorized alternatives that can be put in place that are acceptable. You can just be aware of that also.
Not everywhere, but in particular cases, we have that capability. For example, with ODH monitors, if they are out of service, out of CAL, failed for one reason or another, we can authorize the use of POM, personal oxygen monitors, for individuals who have to enter those enclosures. By the way, we never enter an enclosure after the alarm has gone off. That is only done by fire rescue personnel to verify whether or not it's safe to enter. Another alternative that we can authorize is the use of alternative oxygen monitoring equipment, typically 4 gas meters that we have calibrated and available on site through the ESH organization that monitor for 4 separate gases, including oxygen, carbon monoxide, carbon dioxide, and combustible gases.
Okay. So what happens, I'm asking you guys, what happens if we don't meet accredited control or the available alternative? Then what? What do you guys think?
Can't operate, can't work.
Exactly.
Okay, so, right? And or you may have to evacuate the hutch if you've got this ODA issue. And of course, we got to tell our friends. Okay?
Yeah, and those two come in pretty quick order.
Now, so we're going to leave authorization basis documents now, and now we're transitioning into the USI or unreviewed safety issue determination process, and we start with definitions. So what definition would you guys propose for the first one right there, unreviewed safety issue? What does that mean to you at this point? Unreviewed safety issue. So what I want to point out here, and this will come into play later, is you could really look at it, big picture, in 2 tracks. You can have potential issues with something that's planned. You didn't do anything yet, but you guys are thinking about the Nobel Prize, so you're planning some big things, okay? Or it can be an existing condition. Now, the existing condition scenario is worse because that's happening. So USI can be broken down into those 2 pieces.
All right.
Steve?
Let me,
So why is number 2 unreviewed? Because essentially it should be, it's something which has been previously analyzed, so it should be part of the safety envelope. It should have been identified and analyzed. I mean, it says it was analyzed before.
this is the case of the berm discovery. You analyze the situation where you assume that you had, in fact, 4 foot of soil over the Linux and the booster, but in fact, when you measured it, you found you had been operating, but there was only 3 foot of soil over the booster. And you didn't analyze that situation. If somebody was there, would they have been susceptible to exposure to radiation above the allowable limits or above the shielding guidance that we normally have? So when you have a discovery of a discrepant condition, that's very serious. Much more serious than the first case. Because the thing about the first case, when you plan something new, what happens is that you get a preliminary analysis done. And if it passes the preliminary analysis, you don't have to do further analysis. But if for any reason it doesn't pass the preliminary analysis, that is to say, if the results are going to result in consequences or events or readings or dose rates that exceed the accepted and established safety envelope, well, then you have 2 choices. You could either go ahead with the request because it's so important that you think you could justify this increase in risk to DOE and get them to agree with you, but you can't do it until they do. Or you could sharpen your pencil and change your plan, maybe cut it into smaller slices, maybe back off the energy a little bit, maybe provide a little more shielding, or do whatever it is you have to do to make the result come out to be not a USI, in which case you could do it immediately without further approvals or reviews. So the advantage of a planned activity is you always have the option to reslice it, adjust it, modify it, or alternatively, if it's something that is so compelling or so important or so fundamental to that which you are planning on doing that it's worth the effort, and it's just a matter of effort to justify that additional risk factor to DOE, we do it. For example, when we replaced the room temperature RF in the accelerator with the superconducting RF device, we were not able to do a ARR at the time on that device. We went to DOE with our analysis and we requested an exemption from the requirement, a temporary exemption. It was really a delay, but it was a temporary exemption from the requirement to perform an ARR on the superconducting RF device so that we could install it, test it, operate it with the machine and demonstrate that it works well. We had previously tested it successfully in the test facility, and we had the results of that. We knew what the radiation levels were and the dose rates and the shielding requirements as such. And we were able to, by using the USI process, go to DOE, get them to agree to give us an amount of time to run and operate without having undertaken an ARR, with the commitment that we would do the ARR in conjunction with the routine operation
It still
ARR.
has to happen at a later date.
Yes,
The ARR
yes.
should
We
still
did
be-
it already, in fact, but yes, we got the extension. And that is one of the functions of the USI. So when you have a planned activity, the advantage is you could sharpen your pencil, cut it up into smaller pieces. You can do a number of things so as not to have to get pre-approval from DOE. If you discover something is not as it should be, then you have a positive USI on your hands, then you have to go to DOE. The biggest problem we had, as you may recall, if you've been here for a while, was that missteered beam incident back during the LINAC commissioning time. And the biggest problem was a lack of understanding on the part of some of the people in the facility that represented a positive USI and needed to be treated as such in terms of reaction with DOE.
Okay, so you know something that you believe is amiss that perhaps affects or compromises the credited controls. You raise that up to somebody. You're not a screener right now, but you raise it up. It will undergo a screening. That's a simple questionnaire, 8 questions, very coarse. It's a go/no thing, go, no-go kind of questionnaire, and we're going to look at that questionnaire in a little while. If it goes through here and it's positive, you don't have a USI yet, but it's a potential USI because you said yes to one of the 8 questions, not you, but a screener. It then goes to the evaluator, who really, as Steve alluded to, takes a really closer look, has to get SMEs involved, has to do calculations, and find out, in fact, do we have a positive USI right here? So,
Why
now,
that double step? I mean,
question?
Why that double step? Why not just doing screening and evaluation at the same time to save some time?
Well, it's not really a savings of time. To do an evaluation is a lot more effort than to do a screening. A screening is something that can be done in a matter of minutes because you're basically looking at some very coarse indications. If that which you are planning has no bearing on credited controls and has no bearing on this and has no bearing on that, we could, pass it through without doing any further analysis. But if it's something that does involve the shielding or does involve the settings on the machine, then we have to ask the more complicated questions that are part and parcel of the USI evaluation process. And not only answer them, we have to have the evidence to support our answers. And we have to present it so that somebody else reading it would come to the same conclusion.
By the way, I've been talking like we're relying on everybody just to kind of think about this. As we get more mature, all of this stuff will be in our existing procedures so that when you're modifying something, it will alert you or somebody to do a USI.
Well, in fact, that is already the case. The USI process has been formally tied into over 20 procedures that specifically reference or invoke them. Among the procedures that invoke the USI process are, of course, the USI procedure, management of NSLS safety and authorization basis documents, reporting of events when events are discovered, the procedure for development, issuance, and implementation and use of procedures, or procedure on procedures, which is why that I have to review each and every procedure that gets written. Work planning and control procedure invokes the USI. Authorizing operations and performing maintenance invokes the USI. Procedure for safety system work permits. Anything that has accredited control, when we work on it, gets a separate safety system work permit. Radiation safety component configuration management, radiation air monitors configuration management, PPS configuration management, procedure for software change control. We don't think about this, but things that affect programmable logic controllers and the way the machine operates, that is something we have to be very careful of making changes to. Deviation waiver request, procedure for preparation, review of drawings and specs. I get to see almost every drawing. I get to see every spec, every ECO, every ECR, every ECN. Design reviews, travelers, engineering design plans, organizational assessment process, discrepancy reporting, of course, and events and issues management. All of these things invoke, at some point, the USI process. So you almost can't escape it unless you are purposefully avoiding it.
And as Steve likes to say, it's not just going to be a mental process, it'll be documented. Okay. So, some precautions, limitations taken, again, right out of the procedure. If we have activities proposed again that will result in the USI, we must not commence before DOE gives us approval, of course. And we have to, if we have existing conditions, of course, it gets more complicated, right? We have to try and eliminate, we already talked about that, or secure the beam, of course, before we can go on. And of course, we have to keep everybody informed. Okay. And I said earlier, if we violate the ACE, it's really parade rest or all stop for you ex-Navy personnel. Okay, responsibilities. Who is the authorization basis manager? I asked you that question. Who is it? There he is, Steve Moss, okay? As he's been saying or alluding to, he will assist in assigning USI screenings. He will get involved in evaluations. He maintains all that paperwork, both evaluation screenings. If, in fact, we have USIs and we have to get into this area called basis for continuing operations, certainly Steve will be involved in that. And he dispositions all this paperwork on a computer database.
With help.
Okay? I ask you guys, who is your BHSO or DOE FAC rep? Do you know who it is by name? You guys don't know him?
It'd be a good name to know. He was at the first light this morning, along with a lot of other people. His name is Pete Kelly, and he's a very good engineer, and he's got extensive background in both nuclear and accelerator operations, and he's somewhat more easygoing than some of the other accelerator FAC reps on site. So thank you, lucky stars, we've got him.
Okay, so he will get involved.
Excuse me,
Yep.
BHSO, can you remind me what that means?
Brookhaven site office.
Brookhaven Site Office, that's the DOE office. That's the name they use for their office.
Okay?
That's the DOE side of it.
Yes.
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 Oh, that Peter Kelly. Of course I know.
Oh,
Yes.
good. Good, good.
Okay. So he'll get involved in case we do have USIs and we have to have basis for continuing ops. Of course, he'll be intimately involved in that. Each USI screening has an owner. That'll be written on the sheet. ESH manager, he gets involved in saying, okay, let's ask this person if they'd like to be a screener. Would you like to be an evaluator? Okay?
It's not so much would you like, do you think we need to have screeners and evaluators from particular areas? It's pretty clear in the accelerator side of the house, there are very technical areas where it'd be a good thing to have someone trained as an evaluator in those areas regarding electrical engineering, mechanical engineering, things that relate to the operation of the facility where It's a lot easier to train someone to do USI than it is to get someone who knows how to do USIs all the knowledge and information they need to do the proper analysis of the proposed change or the actual discovery.
These folks approve the USI evals. I ask you, who is the conduct of ops manager? Who is your conduct of operations manager? Anybody
Used
know?
to be Les Hill.
Used to be
Not
Les Hill.
anymore.
Right
I
now,
got stuck with
Steve
that.
Morgan. Okay. Now we're going to move into these flow charts, and I won't
Before
spend a
we
lot of
do,
time on
I
them.
just want to touch
Go
on
ahead.
something that we skipped over. We mentioned the identity of our DOE FAC rep. Now, this person is someone you should all be familiar with, or you should at least recognize. He should be a welcome face, and you should always try and give him time if he asks for it, a look-see if he wants it, and he is ultimately the person who's going to be best able to help us get things done and get things through DOE. There's one other person on site we haven't mentioned yet, but we should remember and think about, and that is Brookhaven National Laboratory's own Accelerated Safety Officer. This is Chuck Schaefer. This is an individual who comes out of what used to be the RCD organization, and still is. He represents the laboratory's interest in following and obeying all DOE rules and regulations on accelerators, and to make sure we don't accidentally, honestly, or dishonestly try and subvert those or get around those or try and beat the system that would put the laboratory in a shameful position with DOE or at risk of losing the contract with DOE, because they certainly don't want that. So he is another individual that I have to work with that is involved in a review of the USIs and the process, and basically has very high standing in terms of what he thinks about what we're doing and how we do it.
Okay. So these flow charts, the last time we gave this training a year ago, A and B were combined. But now we're smarter. And so we recognize it's better if we have one flow chart that deals with proposed activities. Remember, this is just proposals, but you can have a USI, even on something proposed, versus existing conditions. So we have those two flow charts, and then we're going to look at the screening questions. So just a quick little peek at this. And so, again, proposed experiment, modification, procedure, etc. You would ask the question, okay, is a USI screening required? Yes, you're into that procedure, process. Do you have a potential USI? If you say no on all 8 questions, you're kicked out. No further action required. You're done. That gets documented, filed, we're good.
When you say you, what you mean to say is
Screener.
an authorized, qualified USI screener. We have a lot of them. Mostly I do them, but if anybody else wants to, I'm more than happy to just have them do it and just look it over.
However, if you say yes to any one question, now you continue. Now you have to move into an evaluation. Now more people have to get involved. Now, at that point, you may go through after your calculations and arguments. You may say, okay, no, we don't have a USI, fine, you're kicked out. But you may have a positive. You may have a USI, yes, disposition, radiological safety committee review, laboratory ESH review, ALD gets involved, DOE gets involved. Okay, then we're at the end. So it gets more complicated.
But the prime responsibility to trigger this process is ours. It's lying with us. Yeah?
Yes.
So essentially, if we are a bit careless about it, we can just bypass this by thinking that maybe this is within the safety envelope and we don't have to go through this process. So we just don't trigger the
Unless you find yourself doing something that brings you into any one of the 20 procedures that invokes the USI process. If it involves a work permit, if it involves a safety system work permit, if it involves work planning of any kind. Now, chances are if you're doing experimental work and it's covered under experimental safety review or an ESR or an SAF or something like that, you might not hit up against the USI process directly. But as soon as you're talking to your ESH rep or somebody else in the organization, they're going to be wondering, hey, did this get screened? Is this okay? How do you know this is all right?
So I was going to use an example that if I was correct, you did a USI screening for the commissioning activity approval form that we did this morning.
I did that just to have it done in advance, just so there would be no question that it was reviewed, it is authorized under the current state of affairs, and the holdup was, of course, finishing off all the pre-start findings from the prior IRR to allow for that, and documenting that, and having all the other documentation, which included having Dr. Durka's approval and authorization, having the DOE approval and authorization, and having all these things which I put together as the backup for the USI screening that I did that said, yeah, we're good to go. And I also signed off on that document as a result. Yeah.
So this can be done at somewhat of a leisurely pace because it's proposed. Nothing's
True.
happened yet.
And it can be revised along the way. If you find that you're getting answers that are going to drive you down here when you really want to go here, you can revisit what you're planning to make it so that when the questions are asked, the answers come out that way. There's nothing wrong with that. That's not cheating on your taxes. That's arranging your affairs in accordance with the law so as to minimize the taxes you pay.
So what is the actual procedure to propose an activity? What does this mean?
To propose the activity, well, your beamline people, you have your processes that define how you determine what's going to be done at the beamline, and if somebody wants to propose something new, there is a review process that says how you determine whether or not you can do it at your beamline, or if it represents something that's going to require you to change your layout of the beamline. As soon as you decide you're going to change that layout, it's going to reconfigure the beamline in some way to accommodate that experiment. At that point, there's going to be ECOs, ECNs, ECRs, tech specs, or contracts going out, statements of work. I'm going to be seeing it, and I'm going to be reviewing it.
Okay, so let me put it in perspective I understand. So I do work in a station. We decided it's going to cover by ESR process. So that it gives you envelope that things are identified.
That's
and then-
pre-authorized,
So as long as you work within that area,
nothing else to discuss. That's right.
right? So when you have activity that's not covered already, and then you're proposing this, and you can invoke this process.
So maybe, like I say, a better way to think about it is, let's say, for instance, you decided that you take your upstream mask and you want to make the aperture 6 millimeters instead of 5.
Make it bigger, not smaller.
Bigger. Well, no, just change it.
Yeah.
Right? Then that would trigger an ECO.
Yes.
Would then trigger a screening to say what actually, what's going to happen. You're now, well, mask is a bad example. Let's say it was shielding, right?
Yeah.
Shielding is accredited control. You're now triggering this process the same way you're doing this.
Now, just because you're changing the shielding, that doesn't mean we can't approve a revised shielding plan as long as it complies with the laboratory, the directorate shielding policy.
Right.
So just because we're making a change doesn't necessarily mean it's going to be positive,
but it gets
but it
screened.
means it has to be looked at.
Okay, then we get to the example when we have an existing problem or existing condition. Typically, you're talking about an event, which is self-illuminating. So, well, you get your screening. Again, you may be kicked out early on, but you may not be. I'm not going to go through all this,
Don't
but
bother.
it gets more significant, and you may be shutting down the machine.
Typically, this could be as a result of a assessment or some kind of review that took place that finds things that were not as described. A discrepant condition, a non-compliant condition, something that was supposed to be there that wasn't, whatever.
So when we're going to have all those proposals for experiments, are they going to be part of this USI screening process, or not necessarily? How is this done?
I don't think that they're necessarily going to be. I think they'll be reviewed through the experimental safety review
Okay,
process.
they go through the staff. Okay.
And then if they represent, assuming that the beamline has been established and has been commissioned and is authorized and operating, it's operating on a particular design and a certain safety envelope associated with its operation. If the work fits within that envelope, then it doesn't require further review. If it represents something that may require a change to the physical arrangement or settings within the,
Okay, that makes sense. So the staff does this, yeah?
Yes.
The staff okay.
yes.
So now, the next slide.
What Ed is handing out is a copy of a sample USI screening
Well-
form. Good catch.
So here it is. Let's look at this to further impress upon you things that you'd want to be in tune with. So if this starts out by saying qualified screener answers the following questions. So you're not a screener right now, but I just want to give you a sense of this. It says if any question is answered yes, check potential USI box in Part C above. So Part C above, right here, potential USI. If all questions are answered no, check no potential USI in box C above. Okay, so now let's go through the 8 questions. Does the proposed change or discovered condition impact or potentially impact 1, the PPS system? And it gives you examples. Yes, no. 2, ODH monitoring system. Yes, no. It gives examples. 3, radiation safety component. 4, area rad monitoring system or components. 5, rad source terms identified in the SAD. If you turn the page. 6, any critical devices. 7, Photon Sciences operating organization.
You have a second slide on this with the other questions?
Yeah.
All right.
8, operational safety limits described in the authorization basis documents. So this is the screening form. Coarse, but it alerts you to whether or not you have to take a deeper dive.
Clearly, if they're all no, and basically most of them are no because they relate to administrative things, not making changes to these devices. When we say impact, we have to read it as a negative impact, not a positive one or a neutral impact.
Okay. So really that ends the formal presentation. Just to review, we talked about the 2 authorization basis documents. Anybody, what were they? Do you recall? This is the test part. What were the? Yes, the SAT and the ACE. Excellent. Okay. We defined credited control. Who would like to just give us a sentence on what that means to you again? Credited control. Anybody? Credited control.
In the word of the lawyer or in our words?
In your
Your
your words.
Your words are perfectly good here.
I mean, this is all that credit controls. I mean, this is all the components we have implemented into our BMAN to operate safely.
Okay. Components, limits, controls, surveillances.
That don't violate the ACE and the SAT.
Yeah.
Yes. Okay. And we've been talking specifically a lot about your area, so we've done a good job in that. We did talk about the precautions and limitations, which really is kind of a repeat of some of the stuff we already did go over. And then we looked at the 2 flow charts and the USI screening checklist. So the walk away is we want you guys, if you see something, say something, okay? You call the shots. Engage your ABM, Steve Moss.
If you're not sure whether or not you need one, you can call me and I'll tell you without starting one up just because you asked me about it, if you need one. And I will, in all likelihood, do it, and I will do it in a timely basis because that's how things get done around here. Somebody calls me and says, I need the CCO signed out today, and that's generally when it happens.
All right, so we continue to raise the bar.